Yeah, now that I've retrieved my laptop, it's time for our next speaker. She's a native developer at GitHub, Amy Palamountain, everyone.
Hello, everyone. I'm Amy. I'm really excited to meet you all in this big room. It's kind of strange meeting a whole bunch of people all at the same time like this, so please come and say hello after the talk. So before we get started, I'm a little nervous about this. My friend Toby has been teaching me some Swedish phrases, and I really want to lay myself on the line here and show off my Swedish attempts. And in return, I hope I can teach you all how to say hello in New Zealand's native language, Māori. So if I was to speak some Swedish to you, do you think you would interact with me and speak some Māori? Yeah? Okay, cool. So let's do this. This is my part of the deal. Tjena hallå. Herjävlar, jag hoppas det här kommer gå bra. Tack så mycket, Toby. That's roughly how you spell it, right? So now you get to learn how to say hello in Māori. And so how you say hello is kia ora. And so what that means is be healthy. So the way you say it is this portion is said like key, like lock and key. And the second portion is like the oar on a boat, right, to paddle. So you say it all together like kia ora. So do you think you could try that? Kia ora. Awesome, that makes me so happy. So I wanted to chat with you all today a little bit about building desktop applications, which is kind of weird for a JavaScript conference, but we'll get there. So I work at GitHub making native applications. So I make GitHub Desktop. And it's built with native technologies, Objective-C and C#. And honestly, I really enjoy writing native applications in these languages. But there's a new kid on the block, and it's a new way of writing desktop applications with JavaScript. Native desktop applications with JavaScript. And I'm really excited about the possibilities here. So I wanted to share with you how you can get started building desktop applications using web technologies with ELECTRON. So last year, GitHub released a text editor called Atom. And the idea behind Atom was that it would have a totally hackable core. So you, as a developer, you could pick up Atom and start writing extensions and customizations in JavaScript. And it's a cross-platform app, so it runs on Windows, Mac, and Linux. And it's built with web technologies. So it's written in JavaScript, HTML, and CSS. And because it's written in web technologies, hacking it's super easy, because under the hood, what we're dealing with is a web browser. So you get for free all of the fun tooling that we get when we're writing web apps. So how exactly does this work? And how can we apply our knowledge of HTML, CSS, and JavaScript to build our own cross-platform desktop applications? So the science behind the Atom text editor is a little project called ELECTRON, and it was formerly known as Atom Shell. So I just want to get a quick show of hands. It was mentioned yesterday in a lightning talk, but before that, who had actually heard of ELECTRON? Quite a few people. That's great. So if we were to crack open an ELECTRON app and take a little look behind the curtain, we'd see that it combines Node and Chromium. Now, Chromium is the open source web browser project that makes up a lot of the code that goes into Google Chrome. And if anyone's tried building Chromium from scratch, it's reasonably complicated. And it also contains a whole bunch of stuff that ELECTRON doesn't actually need. So what ELECTRON does is it only uses a small portion of Chromium. It uses the CHROMIUM content module. So this contains all of the code that you need to actually render something to the screen, a web page to the screen. So you get for free like HTML5 support, GPU acceleration, and then you get all the dependencies like WebKit and V8. So now we've got the rendering engine behind Chrome coming together with Node.js to form a completely new runtime, the ELECTRON runtime. And Node has supported Mac, Windows, and Linux for a really long time now. And Chromium is also cross-platform, so that means that Electron apps are by nature also cross-platform applications, which is interesting, because when we write JavaScript for a web browser, we can't interact with native components. In Electron, we can. So suddenly we can do a whole bunch of things that we couldn't actually do in a normal web browser. So I don't want to dance around this topic too much. I thought we'd get into it and just see how an Electron app fits together. And to do this, we're going to start by building a sample app called Science. And before we get going, we're going to need to globally install an NPM package called Electron pre-built. Funny story, I actually had to speed that up like 4,000 times because the internet in New Zealand is so slow. That's reality. So the latest version of this package is going to allow you to download those pre-built binaries of Electron, the latest version of Electron, for a given platform and architecture, which means that we don't ourselves have to do a bunch of funky cross-platform builds. And it's also going to add Electron to our path. So now when we run up Electron, what we get here is this empty shell that's ready for us to drag in our HTML, our CSS, and our JavaScript. Now, this is not how you develop Electron apps. You don't just drag in a bunch of code. We're actually going to do something a little bit more sophisticated than this. So we'll get started. Let's see what it takes to put it together. So the first thing we need to do is initialize our package.json file. So we're going to give our app a name and a description. And then we need to tell Electron what the entry point of our application is going to be, the file that it needs to run when everything kicks off. So we're going to name that file main.js. Now, it doesn't exist yet. We're going to create it in just a moment. So that all looks good. We'll clear that out. And the very next thing that we need to do is add Electron pre-built as a dev dependency. So we'll do that with -- save dev. And now we're ready to open up Electron in Atom. Bing. This is crazy because now we have some kind of weird inception thing going on where we've got a text editor that's been built on Electron. Now we're now using that to build another app, another Electron app. It's mental. So we have an almost empty Electron project here. We've got one node module that Electron pre-built and our packages JSON file. So we can see that we've specified main.js as our main entry point. So we're going to go ahead and create that now. We're going to leave it blank for a short minute or two because you and I, we need to have a conversation. We need to have a conversation about what goes inside main.js. So Electron apps have within them two kinds of processes. We've got a main process loop and a render process. Now, when an Electron app starts up, what we're going to do is pass it the main.js file to run, and Electron's going to take that file and it's going to run that inside its main process loop. So the main process can be thought a little bit like a master of puppets. So it's going to kick off the Electron runtime, and it's going to give you access to all of the Electron APIs. And then it's going to allow you to coordinate all of your custom modules and application code that you're then going to write. But just starting up a main process doesn't actually result in any user interface. So you have to do that yourself. And you do that by spinning up browser windows. So inside the main process, Electron has given you access to a module called browser window. And so we're going to use this to kick off a new kind of process, that render process that I was talking about. So the render process is able to take some HTML, which will then link off to like all of your CSS and your JavaScript, and it's actually going to render that to the window. And the cool thing is because Electron uses the Chromium content module that I mentioned earlier, this means you get for free Chrome's multi-process architecture. So that means that each browser window that you spin up is actually going to be running inside its own separate render process. And this is an interesting thing to keep in mind when we're building complex Electron apps, because we can actually use this in a different way. We don't have to always render something to the screen. We can cheat a little bit and use this as a way to come up with a bit of a makeshift thread pool. So if we have complex tasks, for example, that we need to offload off those main loops and execute in the background, we can use this by not actually showing a browser window, but using that background process. So now we can spin up many render processes, be it to actually render content or just do some background work. We need a way to communicate into process. And luckily, Electron is going to provide us with a mechanism to do that. So you can require in your render process, you can require in the IPC module, which is provided by Electron, and then you can send synchronous or asynchronous messages between processes. And then inside the main process, you can easily wire up event handlers to those messages and do interesting things when you receive events. And the reverse is also going to work. There's heaps of really great documentation on the Electron website that describes how to do all of this. So thinking back to our main.js, we're going to spin up our main process, and then inside that, we're going to manage many render sub-processes, and they're going to communicate via IPC, which sounds pretty interesting, I think. But if I had to pick one killer feature of the Electron runtime, it would be that you can actually require in native modules inside a browser context. So in normal web browsers, they run in a sandboxed environment, so you can't access any native resources. But with Electron, you can. So for example, inside a render process, you can actually require in a C++ module, like level DB, for example. You can then go ahead and access the database file off the physical disk, and then in the same breath, render to the DOM, which is crazy. You just can't do that in a regular web browser. Electron's pretty awesome. Okay, so let's go back to main.js. Knowing what we know about the main process and those render processes, we can start to fill in the gaps of that main.js file. So we're going to start by requiring in a module called app, which is something that Electron provides us. And it's responsible for controlling the lifetime of our Electron application. So it gives us notifications to events like, hey, I'm starting up, or hey, a window's opening, hey, a window's closing, the app is quitting. So we're going to also need to require in a browser window, as I mentioned earlier. This is going to allow us to spin up new windows and render processes. And we'll do this when Electron signals that it's ready. So inside here, we're going to create our new window and give it a height and a width when Electron is done initializing. One thing that we need to be aware of is that we need to keep a top-level reference to that main window, and that's because of garbage collection, right? We need to make sure that as our application's running through its lifetime, we don't have our main window being disposed out from underneath us. We need to actually control the lifetime of our windows. So now we're going to run up our app. We're going to give main.js to Electron, and we're going to see what happens. We have an empty native application that sits in the dock, but doesn't actually do anything yet. It's just an empty window. It's just an empty render process, so we better give it something to render, some UI to actually show. So I've dropped in some HTML and CSS. It doesn't actually do anything complicated. I just stole some source off the Bootstrap website. We're going to tell our browser window, when Electron signals that it's ready, to load in that HTML file off the disk. Oh, I let that go too quickly. Dropping in the HTML. We're going to run that up. And here we have it. We have Electron rendering some content. The cool thing is, though, is all the regular web browser tricks are going to work, like media queries, for example. So this is the way that we can start building full screen and minimized experiences. So now that we have one or maybe many render processes, we can start building out our application features. And so in a render process, as I mentioned, we can write all sorts of kinds of JavaScript, including calling native APIs. Like, we could create tray items. So Electron has APIs for this, and it takes a bit of a philosophy on this, where you're going to provide an icon and some HTML and JavaScript to execute, and it'll take care of making sure that the rest of it feels really native for this specific platform. You can also add content to the recent document lists or the jump lists. Unfortunately, this API only exists for Mac and Windows right now. And you can also create application menus. So we're going to go ahead and try and create an application menu. So we're going to create a module called application menu. We're going to declare a function and then export that as our module. And then we're going to add to the prototype a setup function. We're going to require a menu. Now, menu is something that's required by Electron. It's going to take care of all the native components. And we're going to call this helper build from template and pass it an array. And an array that is going to roughly correlate to the menu that you would see at the top of your app here. But it might also contain sub-menu items. So the first item in our list is going to be the first menu item that we see. It has a sub-menu, preferences, and quit. So these are just some dummies for the moment. Then we need to require in our app module, we're going to set on our app what the main application menu is. And then we're going to flip back over to our main.js file, require in our custom module, and then when the application is ready and starting up, we can set up our menus as well as starting up our browser window. So let's see this in action. We'll run up Electron, and we have a menu up here that has two submenus, preferences, and quit, but it doesn't actually do anything right now. So as a really quick example of how we can wire up all of our menu items, we can just provide a function to execute on click. And in this case, we're just going to call application quit. So we'll run that up again. And now this time when we click quit, our application actually does exit. So this is why I'm really excited, right? Like, we can do all of these native feeling things, including quitting an application. It does get more real than this, though, because remember, we can create those tray items and all those neat things. So it's created this like super awesome runtime for accessing native libraries and doing things that feel really native in JavaScript. But what use is all of that without getting our applications out into the world? I mean, it's pretty awesome when we write some code and people actually use the code that we write, I think, I hope. So there's a handy NPM package called Electron Packager that allows you to package up your applications and actually distribute them. So this is going to allow you to package up your Electron apps into OS-specific executables. So we're going to create science.app and put it to the App Store. So we're going to start by installing the Electron Packager as a dev dependency. You can also install this globally if you want to quickly do this and have it added to your path. And then we're going to invoke the packager. But before we do that, I just want to check which version of Electron I'm running. So I'm just remembering that. Then I'm going to invoke the Electron Packager module. I'm going to invoke it against the current directory with an application name. And then I'm going to specify which platforms I want to create a build for. And in this case, I'm creating a build for OS X and for a 64-bit architecture. And then I'm going to say which version of Electron I want to build with, and I'm going to build with the installed version. So you can specify whichever version you want. Now that's going to go away, and it's going to package up our application for Mac. So if we list the contents of this directory, we will see that we have science.app. And if you run it up, this is what you have. You have an application in your dock. It's running out of that directory. It's not in debug mode. It sits in your dock just like any other regular application. But what we really want is cross-platform builds, right? We really want people on all operating systems to be able to run the sweet code, the sweet apps that we're writing. So we're going to go ahead and specify, we're going to create a build for all platforms. So again, we're going to specify we're building the current directory with the app name science, and we're going to platform all. We're also going to architecture all, so this will give you 32-bit and 64-bit for this version of Electron. And what that's going to do is it's going to go away and download on my incredibly slow internet all the way in New Zealand. It's going to download all of those permutations and create builds of our science application for each of those OSs and architectures. When it's done, it's written the apps. We're going to open up Finder, and we can see that we've got some distinct builds here. We've got science.app, which we can then distribute. We've got Linux. It's been packaged just as a Linux application would be. And we've also got Windows. We've got all of the DLLs that come with building a Chromium app in this way. And there's our executable. So we can take this Windows build and we can copy it over to a Windows machine. The funny thing is being a native developer, this is my life, switching between VMs like this. So we're going to copy that over, and when it's finally done, we're going to open up the folder that we've copied to. We'll see science.exe. We can run that up, and we have our exact same application with our menu bar features and all. So media queries are responding in the same way as they did on OS X. Nothing has been done special here. The only difference is that we're packaging it explicitly for Windows, and we can quit our application as we did before. Right, right. So there's a whole bunch of really great packages that can help you get started, like Electron pre-built, which is going to build those, it's going to build Electron for you for those particular platforms and architectures, and Electron Packager, which is going to allow you to package them up so you've got OS distributables. But in order to get going, like with a proper Electron app, there's a lot of legwork that needs to be done. You have to create a build system, build scripts that you can execute on your CI, all of those sorts of things. And this takes quite a few days worth of work, like 3 or 4, like a week's worth of work. So to help you, there is a handy NPM package that I've written called Electron Accelerator, which is going to take all of the things that we've talked about here and combine them into a one-step process. So you can install this globally and then use this package to initialize a very unopinionated scaffold of an Electron application, which is going to give you easy building, release, packaging, and auto-updating for your Electron application. So we're going to install this globally. And then we are going to create a second project directory, Science2. And we're going to invoke the Electron Accelerator in this directory. It's going to ask us for some information about what our app's all about, like what the author's name is, what the name of our application is, description, where it's going to live on GitHub, all of those. I also just want to point out that there's a rainbow line across the top here. It's amazing. We specify what platforms, what architectures, and whether or not we want Windows releases. And I'm going to come back to that in a moment. And there we have it. If we list the contents of the directory, we now have a very basic Electron app. We can go ahead and run, we've got a README here, which tells you how to get started with building, releasing, debugging an Electron application, so anyone can start collaborating with you right away. You don't have to think about setting any of this up yourself. A packaged JSON file, and then a set of handy scripts that you can use to get yourself up and running. So we're going to go ahead and we're going to run script bootstrap, which is basically just going to do an npm install. Now, I've seen Kate's npm talk yesterday about npm build scripts. Pretty sure that's my next task, is to go ahead and refactor this to use npm scripts. I learned a lot in that talk. This is going to go ahead and download Node Inspector, because that's required for debugging the main process loop. Who's used Node Inspector? Yes, it's very slow. Very, very slow. But that's currently the only way to debug the main process. So that's gone ahead and bootstrapped our application. I'm going to clear that away. And now we can script build for all of the specified platforms that we said in our setup phase. It's going to go ahead and create our builds for us. And now we can run up our application to test while we're developing with script server. There's also a script server debug, which is going to set up your Node Inspector context. And there we have it. There's nothing else in there. The application is very, very blank, and it's ready for you to come in and build your application in the way that you want. It's just getting you started as quickly as possible. One npm package, and you've got it all ready to go. So one thing that I haven't talked about yet, and I've just mentioned briefly, is auto-updating of Electron applications. So the idea is that similar to the way Google Chrome works, where you deploy updates to your application, you want your users to have those automatically installed silently in the background, so that when you start up your application, they get the latest version, the latest deployed version. So Electron apps use updating software called Squirrel. And Mac, if you've been an OS X developer, there was an updating software called Sparkle, which Squirrel actually supersedes. So on Mac, the implementation requires you to install a Squirrel server, and then you're going to upload your new packages to the Squirrel server, and then your Electron app can contact the server and install the version that it tells it to. Now, Electron has built in an auto-updating module for a Squirrel server. So you don't have to write any of the auto-updating code. It just works. It doesn't quite have baked in it yet an auto-updating module for Windows. And the Windows auto-updating software, Squirrel, works a little different. It actually runs on top of NuGet, which is a Windows package manager. And it's pretty simple. You can just upload your releases to a file host somewhere like S3. And then the client is able to check whether there's a new version, a NuGet package to download, and it will download it in the background. So as I said, the auto-updating module has actually only been implemented for Mac. And for Windows auto-updating, there's an external package that you can use to get that started on Windows. But this is all baked into, almost all baked into the Electron accelerator. So right now there's a crude implementation for Windows uploading to S3. And in the next couple of weeks, there will be implementation for a Squirrel server. So the idea is you can run the Electron accelerator project, have build, release, and auto-updating baked into your app from the get-go. All you need to do is write your application. So that was Electron. It's a cross-platform technology. It's built with web technologies. It's the science behind Atom, and a growing number of really popular applications like Slack and Visual Studio Code, which is the new cross-platform IDE from Microsoft, are all written with Electron. So thank you very much for listening. I'm Ameep, and you're totally awesome.